right, guys. My God, we made it. All right, so time is of the essence here, and we're going to get rolling. I'm glad to see everybody online. Sorry, we had to switch gears a little bit. Things got a little confusing with preparing food and trying to be at two places at one time. So let's start with chapter 4, utilizing systems. And this one is on electrical. Now, this class is not going to make you an apprentice for electricians, okay? But it's just some basic knowledge of what the heck goes on in this world. All right, so the illustration on the right on the first page of chapter 4 shows an underground system. This is something you would not likely see in the city of Philadelphia. But if you're working in the suburbs, it is not uncommon to see a transformer box on the front lawn, side lawn of a parcel. That transformer box underground is then entering up into the meter. This is being fed and supplied its energy from underground, which the illustration doesn't show. Like, how does the transformer get its energy? Well, it's getting the energy from the street. So the street, when they developed this parcel and put a development here, in the ground in the street is water, sewer, electricity. So the electricity is coming underground to the transformer. The transformer is then going underground and then pokes its head out by the side of the house and enters the meter box. This is where the energy, the electricity is coming from. From there, it's going back down and entering, in this illustration, to a basement area, a lower level area, which is where the service panel is, called the circuit breaker. And we'll talk about that. Now, 100 amp service is very customary, especially in the city of Philadelphia. Our row homes are not necessarily exceptionally large. 16 to 1700 square feet is an average or less. And 100 amp service is adequate. The bigger the house, the more energy we need. So with that said, we're going to scroll down a little bit and you're going to see how the energy can be brought into a typical row home. On the right, on this page, on page 30, lower right, overhead service entry, see how there's that swinging line, which says to pole on the left, and there's that swinging line to a meter. This is just exactly what we see in the city of Philadelphia. Go anywhere South Philly, and you're in that backyard, and there is a spaghetti of wiring over your head. This is that line coming into what is called the service cable line. The service cable line is the line you see running down the back of the house. On occasions, on a home inspection, a home inspector may comment that that line connecting to the side of the house is too low. It's at a dangerously low level that somebody could accidentally hit with a ladder. Kids could hit it with sticks. Too low. The only people who can correct that tension on that line is PICO. So know that if you need to respond to that on a reply to home inspection, that is a PICO correction, not the seller, not Joe the electrician. That is a PICO repair. So when this line attaches to the side of the house, the service cable line comes down the side of the house, enters the meter, goes through the meter, and then again, you see how it enters into the lower level to where the circuit breaker is. It also shows on a slab construction here on the left. So not all of our homes in the city and clearly in the suburbs have a lower level, such as a basement. And here, the basic concept is the same. It doesn't have the swinging line like we have in South Philly, but you'll see that it has a lower ground entrance from the transformer that then goes up to the meter, and then in through the wall it comes, and it's going to enter into where the breaker is. And we're going to go into a much deeper understanding of the breaker box. Okay, so we have a general idea. How does the electricity even get in the house, for crying out loud? Okay, well, now we have a pretty good idea. It either comes underground, it swings across, and it attaches to the side of the home and comes in, right? Okay, now these are a couple things you want to know. And this, I have to be so gentle with this because it's a little cranky. On the right-hand side, there's a long rectangular box. Must know, must do electric. These are very basic things to know, okay? Properly installed electrical systems are very safe and efficient. To prevent safety problems, though, you should understand the basics. Know where the main electrical disconnect is located, and we're going to talk about that and how to use it. To prevent shocking, any outlet near water, such as next to a sink, an exterior outlet should be a GFCI. This is called a ground fault interrupter system. And we'll have an illustration of what that looks like. So, rule of thumb, within 6 feet of water, we need to have a special outlet. Know which outlets are GFCI protected and test your GFCI outlets monthly. Avoid using extension cords. Extension cords are a real hazard. The older the property, the less outlets we're going to have. So especially at holiday time, when people are trying to put candles in the window, we got the Christmas tree and it's a warmer winter, so we got a fan going because the house is full of people. We've got all of this electricity running through these not necessarily best grade of extensions. They overheat and they can cause fire. So extension cords are a big problem. Never attempt an electrical repair yourself unless you know exactly what you're doing. Wise statement. Never perform rewiring, use a professional. Identify each breaker fuse, and we'll talk about what a fuse is, and to which outlet. And we're going to talk about marking your boxes. This is something that is customarily addressed on a reply to home inspection. The home inspector will make a notation if the box does not identify what that breaker or fuse is allocated for. Talks about if you're replacing a fuse, this is so rare, fuses anymore, but it also applies to the fuses or ampage that you would change in a box. You have to keep things of equal. If it's a 20 amp breaker, you want a 20 amp breaker to replace it. 15 with 15. You're not putting mix match numbers in the box. Know how to reset a breaker? Pretty easy, and we can talk about that. Never cut or modify electrical plugs or outlets. Okay. Basic stuff. Let's look at the illustration on page 31 on the bottom left. Electrical main circuit panel. This is about as generic as it gets, but yet very effective. Please note on the top, main breaker turns off all power. The main breaker, excuse me, should always be at the very top of the box. Please note that this illustration is not showing the door that covers all of these breakers. There is a door, metal door, that covers it. So when you open the metal door, and the hinge would be on the left, so you would open the door, this is what you're looking at. Now, on that bar, that vertical bar, almost in the middle of the two horizontal bars, is forcing both of those breakers to move simultaneously. It's a breaker bar. You can't flip half of that. You have to be able to flip all of it. And that breaker bar mandates that that's how that's going to happen. Pre-printed on that vertical bar almost always indicates the ampage coming into the house. Is this 100 amp that would be etched in there? Is it a 200 amp that's etched there? 150 amp that's etched in there? That allows you to know what the ampage is. But by turning off that main switch, shuts all the electricity off to the house. Now, what if you open that box and you see the main breaker on the bottom? That main shutoff that we see here on the top, the 2-bar system, is upside down and it's on the bottom. As an agent, what is that telling you? And I'm going to tell you what that's telling you. That's telling you a non-professional electrician installed that box. It is upside down. That means Uncle Joe's been here. Uncle Joe's been in this box. So be very scared. To note that somebody put the breaker box in upside down is enough to go running in the woods screaming, because that's a prelude to other things that are not done properly. Never, never should this breaker main shutoff be on the bottom. Okay, now, 30, 40 years ago, there was a manufacturer, excuse me, who manufactured breaker boxes without a main shutoff. And please forgive me, I forget the manufacturer name, but immediately a home inspector will identify that. That is a problem. There should always be a main shutoff. So things to look for when the box is open. Now, you'll note on the right-hand side of this main circuit breaker, there is another double-barred breaker. And it's indicated to say 220 voltage. And again, it has that vertical bar that's forcing both of these breakers to be turned on and off at the same time. That's a heavy-duty system. So the question is, what in the world today needs so much power? So much power for a 220 volt would be one, a range, an electric range oven draws enormous amount of electricity. The other appliance that draws enormous amount of electricity is an electric dryer. They too are going to need these big double bar systems. When you look below that, it indicates a 110 voltage single breaker. Now, it may surprise you, but a refrigerator only needs a single 110 voltage to run. Your lights. Different pieces of a kitchen will be on separate breakers. It is recommended that microwaves be on a separate breaker. So multiple appliances, multiple outlets can be on one breaker for sure, but it has to be indicated what it is. You'll note below where there are rectangular boxes that have nothing in it, that's called blanks. And that's where we can add additional electrical service to this box because there's availability to add more. Okay, does that make sense? All right, let's scroll down a little further. Now, how a circuit breaker resets. Oy. Okay, so think when you were a kid. Your mom yells, now depending on the age of the house, you're going to hear, I blew a fuse in the kitchen. That's an older house. On the right-hand side, you'll see the illustration, electrical main fuse panel. This is a much smaller panel with an older system. Fuses are much older and would not be any greater than 100 amp service in a fuse box, generally speaking, okay? So these little buttons that you see on the bottom here, there's 2 rows of 4, are glass buttons that are threaded so they can be screwed in, known as the Edison type. There's also a cartridge type of glass fuse you see above that. This is what you would need to replace when your mom was yelling down the steps. You rarely see this anymore. Let's pay more attention to the circuit breaker reset on the left-hand side. Now, depending on the manufacturer type will depend on which of these resets. Now, when a breaker is in proper usage and is working, the first illustration horizontally where the off on is the on position. Notice the little black handle is very close to the on position. So that means it's functioning. When that breaker has tripped, it now flips to the off position. So it switches from the right side to the left side. And then you have another version of it if you were looking down upon it, how it went from the right to the left, okay? That's how we know that that particular breaker has tripped. To reset, move the switch to the positive position. So your mom yells, "Oh no, something blew." You run downstairs, you open the box, and you would look to see where all these positions were, and you'd say, "Oh, look at this one. It's way to the left. It's in the off position." All you do is you take your thumb and push it back to the right position, which allows the electricity to run through that outlet she needs, okay? Now, here's another type of reset that you may see. The on position is on the far right. The tripped position is in the center, and the off position is all the way to the left. Move switch to the off position and then to the on position. You run down the steps and you look. You see everything is to the far right except this one, which is caught in the middle. You take it to the far left and then you take it to the right. So you take your thumb, you push it to the left, and then you take your thumb and push it all the way to the right. It has now been reset into the off position. A third type of manufacturer tripping kind of scenario would be a red light indicator. You run down the steps and you look and see that even though the breaker is all the way to the right, there is this red flag that's identifying it had tripped. Again, you're going to take your thumb, push it to the left, and then turn it all the way to the right. That is going to reset this for you. Okay. We scroll down a little, maybe. Oh yeah, there we go. Okay. Talks about fuses. It's a larger artist rendering of fuses, which we don't replace and see very often. Okay, type of wiring. Plastic sheathing covers some wiring. There is metal conduit. That's a word you need to be familiar with. Conduit is like a sheathing over the wiring to protect it. Conduit can be metal. It can also be PVC. So you add a shed to your backyard, and now you want electricity. You have to go underground, so the heat I'm sorry. So the electrician's going to take the electricity, go underground, go all the way to the shed, and to protect the electric from exposure to the ground, it's very possible they'll put it in metal and or PVC type of piping to protect it. There's also a flexible type of metal, again, to protect the wiring. But the word conduit is the protection shield on these wires. Okay, different types of outlets. There is 110 versus 220. Okay. Typically used with electrical systems can be confusing. The 110, 220, 240, God knows what, right? But you really don't need to sweat it. In fact, electrical utility companies don't provide any exact voltage. Just remember this. Electricity is provided to your home with a normal approximately 110 or 120 voltage per wire. When you connect between two live wire feeds, you double the voltage, which means you go then to a 220 or a 240 voltage. So you can call it 110 or 120 voltage for a smaller appliances, and 220 or a 240 voltage for a larger appliance, such as your range and your electric dryer. 110 voltage is what's provided to all outlets, that regular outlets we have, light switches, light fixtures in your home. So let's take a look at the artist rendering of the faces of different types of outlets. Now, the first one you see on the left, we're going to call it a face because it kind of does look like a face, right? It's a 110. We see this all over our homes today. We plug in lamps, we plug in radios, we plug in appliances into this. You'll note that one eye is larger than the other eye. Over time, this face has changed. Many, many years ago, both eyes would have been the same size. Now, the mouth is the ground. The ground that supports the electricity for safety is grounded. You've heard the term, is this grounded, right? Okay. You'll note that a 220 with a 20 amp voltage is winking at you. And to be honest, you don't see this one that often. But again, this is for a system, appliance, a window AC, a wall AC unit that needs more energy to work. The big guy on the bottom is what you have seen repetitively. And that is the 220 30 amp. That's that big, probably 3.5, 4 inches wide by 6 inches high black instrument behind or bolted on the wall for your electric dryer. Big guy. And that's where that electric dryer needs so much energy to perform. And that's where you're going to see this much larger 220 30 amp outlets. Electric polarity. Polarity is an important concept for safety's sakes, and you need to understand the basics. In a home inspection report, you will read very often that it was noted reverse polarity was found and on various outlets. What does that mean? Electrical circulates through wires just like water moves through a hose. Remember, we spoke about closed systems when we talked about the ductwork. Well, closed systems are not only in plumbing, but closed systems are needed in electric. In the case of a lamp, for instance, electricity pulls through the hot wire and lights the bulb. And then that energy returns through the neutral wire. It runs up, lights the bulb, and comes back down. Electricity goes up through the hot wire, comes back down through the neutral to light the bulb. So what goes up has to come down. It returns to itself. Electrical grounding. Now remember, the mouth was the grounding wire. When you're looking at outlets in a very old home and you do not see the mouth, you just see two eyes, it's telling you that this electrical service is pretty old behind the walls, because they don't even have the third wire in the wiring in the walls for our ground. Electrical devices with metal housing, such as stoves, dryers, tools, often have a ground plug. A ground plug has a third round connection. Grounding plugs provide an extra layer of safety by grounding the metal housing to the device. Never remove the grounding device from a ground plug. For instance, you're in an old house and the plug you want to plug in has a mouth, that round one, but your outlet doesn't have a mouth. There are those who would cut the mouth with a pair of shears, metal cutters, so that the two prongs can be used only, the two eyes. This is not a good idea. This is not the way to do this. There is no grounding now to that. On the right-hand side here, you'll see the illustration of just the two-prong outlet, the old-fashioned, no grounding. It has no mouth, right? And as you go down, you'll see an outlet that has the mouth and the rounded third piece, which is the grounding. If the property has reverse polarity, where that outlet was installed by a non-professional, that's the only time you're going to have a home inspector identify outlets with reverse polarity, is when Uncle Joe has been there. And reverse polarity is when the wires are crossed. So what happens? Stereo equipment may buzz, electrical and computer equipment may be damaged, lights and lamps pose a serious hazard, because when the switch is turned off, it would turn off the neutral or the return wire, not the live hot wire. So the live hot wire is still on, even though the light switch is off. See how that's dangerous? Okay. So reverse polarity is something very important to note in your replies to home inspection. A novel concept here, buyer agents. You have to read the entire home inspection report. You should be at all of your home inspections along with your buyer. This is not an opportunity for you not to go. This is the prime opportunity for you to hone in and have better skills regarding the mechanics of the home and following the home inspector around. Ask questions. It's okay to ask questions and get a better understanding for both you and your buyer of the quality of the home he or she is inspecting. Okay, GFCI, which is your ground fault interrupters. All right, I said we would talk about this further. Now, ground fault interrupters come in various ways, and one, which a lot of people don't realize, actually can be in the breaker box. is where the ground fault is located. And just as other breakers, you'll note that when it's in the on position, it's at the far right. When it's tripped, it's in the middle. And when it's off, it's on the far left. Now, look just below that to the illustration of 016 on the bottom of page 36 on the left-hand side. This is what we're talking about. This is those different looking receptacles. It's not the circular two-face ones above each other. These look very different. And there is a test and retest button on them. This is a ground fault circuit interrupter. This is what you're going to see in kitchens, bathrooms, utility sinks, and there are special ones that are for the outside electric of a home. On the right-hand side, ground fault circuit interrupters that run downstream. So you're doing a home inspection and you're with the home inspector and you look in the kitchen and all you see are these round faces. And you say to yourself, huh, I bet there's no GFCIs in here. Be careful, because there very well may be. You can have a ground fault interrupter in this more rectangular look that protects the other typical routine outlets. So the protection can run from one outlet to the next. They don't always have to look just like this rectangular one. There can be one that is the primary, but it is wired so that it is protecting the other outlets down the line. You'll note just below that, it says arc fault circuit interrupters. All arch fault circuit interrupters were most commonly found either A, in the electrical box, as you see here. And what was the purpose of them? The purpose was to prevent from sparks happening. So you're like, I don't understand. Okay, so a fire is reported to have started in the bedroom. You're like, now how did that happen? Nobody's cooking in the front bedroom. Nobody had candles in the front bedroom. How in the world did a fire start in the front bedroom? So let's talk about this. And we're going to talk about our two-story center, middle of the row townhome in South Philly. It's 120 years old. We have limited outlets. They didn't need the outlets we need today. But you're moving in, you've got a large bedroom set, and the backboard is just making it up against the party wall, right? But you have two nightstands, of which you have lamps on. And you're like, I gotta have to have electricity here. So to get that plug that's being smashed up against the headboard, you just about squeeze it in because it's being smashed by the headboard. And you turn on the lamp and you go, great, it works. Little do you realize is that because those two eyes, and hopefully there's a mouth, are not square into the receptacle. They're kind of cocked on one side because you had to squeeze it in there to get it to work, is causing an interruption of the electricity flowing through the system. So it notes here a dangerous arc fault is likely to occur with damage or frayed electrical cords. The AFCI is installed in the main circuit panel or as a special outlet and has a reset button on its face. If there is a break in the closed electrical connection causing an arc or a spark, electricity wants to connect to itself. And if it's been interrupted, it will jump. It will try to jump to correct itself. In doing that, it's going to cause a spark or an arc. And oftentimes, this is the culprit to bedroom fires. Safety codes today mandate that all bedrooms have to have an arc fault circuit interrupter. Okay? Hope that makes sense. Let's go to plumbing. All right. Water service. Most homes in urban areas receive water from a municipal water system. The original water source may be a lake, river, or large deep wells and storage facilities. Municipalities are required to test water for safety and purity. Often they filter the water and treat it with chemicals. Okay, that's how the city water, municipal water works, right? It comes in, it's inspected often. Many years ago, I was told, this may have changed, that the Philadelphia water is tested 7 times a day to confirm that the bacterial level is where it should be, and there is no contaminants above and beyond what the norm should be. Okay. All right. So how does this water get into our home? Okay, here we go. We look at the water supply system in a cold climate area. So we're going to consider ourselves a cold climate area. If you look at the illustration on the left, it starts where the street is and the curb. Below the street, where we spoke about earlier, is the source where all this energy and massive functionality comes from, the street. The water lines are there, the electric lines are there, the sewer lines are there. So the water main is below the street. The water main has piping that comes in to where the curb valve is located. And that every property has one of these. So again, let's imagine our 2-story, 3-bedroom, 1-bath, middle of the row home in South Philly. As it comes through, it continues through the foundation of the home and enters into a metered area. Now, more times than not, our gas and our water shutoffs are on the front wall of your basement. That's where you're going to find these things, because the access point to them is from the middle of the street, right? So from the middle of the street comes into the parcel. So where your meter is a black, round encasement with 2 pipings coming. All right. In the best of all scenarios, there should be valves, shut-off valves, on both sides of the meters. Okay. If you look further down in the circle, it illustrates, if this was a slab type of situation, how the water would have come through underneath the slab, then penetrates the piping up through the slab, and that's where the water would enter the lower level. Okay, so there's different ways it makes access to a basement type of area or slab. The illustration on the right is showing where water mains can be shut off. Now, this varies, And on the illustration here, it's actually showing something that's really important. The one on the left is showing a hose bib, and we're going to talk about that again. How the water is coming from inside the home and goes up the wall and then goes out to where you hook on your hose, right? And you need to be able to shut that off. And we're going to talk about that. These are different kinds of valves that are throughout a home to shut water off. Before the meter, after the meter, depending on what the situation is. If the meter's leaking, you want to shut the valve before the meter that keeps the water from the meter to the street from entering the home. If you're doing work on the house and plumbing and you need to shut the water, you will shut the valve after the meter, and that's keeping the water from the meter moving forward through the home. Things to know: make sure that all adults in your home know how to turn off a main water shutoff valve. Okay, this is really important because water running constantly is never a good thing. We're going to basically have very basic conversation here about well water. What I will tell you about well water is never, 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 ever do you represent a buyer and not have the well water tested. It's tested for various reasons. The well water must be tested for A, is the well producing enough water which meets the standards of living for X amount of people in a home? Number two, is the well safe to drink? If this is a well, the township and the city have nothing to do with it. It is the responsibility of the homeowner to make sure that the water they're drinking is safe. So it has to be tested. Never, I don't care what they tell you, they as the buyer, this has to be done. Now it talks about well pumps and how they function. It will also talk about softeners for water and how pressure tanks work. This is all over our pay grade, but just note, this is all part of that type of system. All right, so we don't have to go crazy with this. All right, let's go to, what page is this? 42. And on 42, we're going to talk about water heaters. It's not a hot water heater, it's a water heater. The water heater produces hot water, but that particular instrument is known as a water heater. A water heater is a storage tank. It stores the water that is average use in a household any given time. Has a burner on the bottom, and we're going to talk about that, that heats the water. The illustration on 42 on the right, PO82, is a really good slice of a water heater. So let's start at the beginning. If you start at the beginning on the right-hand side, you'll note it points to the piping that says cold water intake. Okay, this is how the water, once it comes into the home, is then funneled into the water heater. So the water goes into the tank from the top and is hosed down to the bottom. Oh, is my shit in? Okay. All right, so you'll see there is also a water shutoff there. All right, now the water goes into the tank. Now, how does this water get hot? Oh, you go all the way down the bottom of the tank and you see where it says burner? That is just that. It's a burner that's flamed up, and that flame is heating the tank and heating the water. The water is in the tank and it's getting heated. Now, let's go to the left side. On the left side, we see a couple things at the top. We see that big corrugated piping we spoke about earlier when we were talking about HVAC. That is the piping that is going to the chimney to remove the carbon monoxide, right? We spoke about that. This is a gas-fired system. It's an oil-fired system. Therefore, it's burning off the residue from the combustibles. So it's got to get out of the house. So it's got to go up the chimney. The next pipe you see is how this hot water leaves the tank. The hot water on demand is called for, and it runs up the top of this tank and goes out to the rest of the house. But in this illustration, you will note that this is a gas-fired system. And how do we know that? On the left-hand side, you see the gas supply. And the gas supply is coming from the main gas source. As you come down the pipe, you'll note there is a gas shutoff. And there is the temperature control for the gas. Now, the gas line makes a 90-degree turn. And that 90-degree turn goes in to fuel the burner. The temperature control for the gas is on the outside of the unit, where you can increase the heat of the tank of water or decrease it. Now, there's something I want you to note. On this gas piping, where it makes that 90-degree turn, you'll note below that is an additional couple inches of piping. And you're like, what is that for? I've known it to be called a dog leg. And you say, but I still don't understand what you're talking about. Okay. As the gas comes down the pipe, gas will have some moisture in it. Because water is heavier than the gas itself, when the gas makes that 90-degree turn to go in the system, if there's any moisture, it will drop below and into this dog leg, where eventually it will evaporate. All right, with that knowledge, you're at the home inspection with your home inspector, and you note that the water heater does not have this extension pipe. What is the first thing you're going to think? Oh, Uncle Joe's been here. A non-professional plumber or a non-professional contractor installed this water heater, either didn't understand the purpose of that additional piping or opted it wasn't needed. It is needed, hence why it's designed to be that way. Little idiosyncrasies of shortcuts are always need to take note of, because it's very possible a non-professional has been in this home doing things. Okay. Now, the next page, we're going to talk about the temperature of a home. We're going to look here on the top left, set water heater to 120 degrees or less for safety. Now, at 120 degrees, it takes more than 5 minutes for someone to obtain a burn, a serious burn. As this jumps by 10 degrees, so does the seconds it takes to get burned. At 130, it's 30 seconds. 140 is 5. 150 is 1.5 seconds. 160 is a half a second. Individuals with small children will obviously have this scaled way down, with fear of a small child in the tub touching the hot faucet and burning themselves. I personally have no small children, so my temperature is hotter for my dishwasher, my washing of clothing. I have an increase in heat I prefer, but I have no children. But this is a really good illustration for first-time home buyers to understand where to set their water temperature at. If you look on the right-hand side, it's going to talk about the mechanics of an electrical water heater. The control panel is not visible on the outside of the unit like a gas one is. Remember, it was on the bottom and it's a turn dial. On an electric one, it's behind a metal panel that you have to remove the panel to set the temperature and then replace the panel. On an electrical one, as we go down further to look at the illustration, there are some similarities. We'll see that the cold water enters from the top, just like the gas one did, and has a shutoff valve. You can see how it enters to the lower level of the tank. In an electrical water heater as this, the heating element is located inside the tank, not necessarily at the bottom at all, as the gas or the oil ones are. And then the hot water on demand comes up through the top of the tank and exits out to the rest of the home. Okay? The electrical feed, how it is energy sourced, happens from the top. And at the top of the tank, you will see the electrical wire that connects the tank to the heating, for the heating element to heat up. Now, very important piece of information, which is on all tanks. On the right-hand side, if we're still looking at the electrical one, you'll note the arrow points to a temperature and pressure relief valve. This is a very important valve. And you say, well, why? And here's why. Where on this illustration it is located is close to the top of the tank, both in gas and electric. It's made out of brass and has a air valve, metal air valve, and underneath the brass, if you put, there's a hole. If you put your finger in there, you can feel the ridges, which is the threading for piping. That temperature pressure relief valve is there in case the water heater malfunctions and the heating element overheats, and the water just keeps cooking and cooking and cooking. One of the major insurance company years ago, State Farm, one of them, Erie, somebody had a commercial where the camera was across the street looking at a Cape Cod. And all of a sudden you saw a water heater blow out of the roof of the Cape Cod. That's for real. That could actually and has happened. And you're like, oh my God, how did that happen? The pressure in that tank got so great, it was like a rocket through the house. This temperature pressure relief valve is gauged so that if the water exceeds a temperature that has been preset, it will force the hot water and the pressure to expel out of this chamber, this brass chamber. Hot water will spew out, Now, when it spews out, it releases the pressure from inside the tank, preventing it from shooting 2 stories in the air. But here's the situation. If this tank is malfunctioning and you don't know about it, and you are walking by it when it releases and spews boiling hot water, for the average adult 5'8" to 6 foot, it's going to hit them in the upper shoulder or chest. For a child, 10-year-old, it may get them in the face. Tragedy for whomever might be near that when that should expel. To this, where I said underneath this brass fitting you can feel threads, is because that is what is called a female threading. To that, an extension pipe needs to be added to within 6 inches of the floor. So if the tank is expelling the water, it doesn't splurt and spew out the side. It runs down the extension pipe to the floor. So regardless as who might unfortunately be by that, the worst is going to happen is that their feet are going to get burnt or the bottom of their legs. So it is mandated for FHA-VA and definitely a safety concern in a home inspection report that all water heaters have an extension pipe on the temperature pressure relief valve. Extremely inexpensive. It can be PVC. It does not have to be copper. It has to have a male fitting on the outside for $10. You can run to Lowe's and get this, and then screw it inside that brass fitting. So now you have complied with the safety of having a temperature pressure relief valve. Okay, I hope everybody gets that. Okay. Again, it talks about how the temperature is elevated or reduced. Again, another illustration here about the temperature pressure relief valve showing of excess pressure will cause the lever to release boiling hot water. Some must-knows, must-dos about water heater to understand them. We go below that and it shows an oil-fired water heater. You do not see this very often. But again, the basics are always the same. The water comes in from the top, fills the tank. The tank is heated, in this illustration, by the oil burning fuel, the fire coming in to heat the water in the tank. You have a temperature control, how hot you want it. You'll note on this one, the temperature pressure relief valve is there. It just happens to be on the opposite side. The same thing happens. This is oil. So carbon monoxide is released from this. Therefore, again, you have to have your chimney at the top, that corrugated metal going to the chimney to expel the carbon monoxide that has been produced from the fuel of the oil burning to heat the water. Okay, piping and valve. Let's look at the water distribution to a home with a basement. All right, so here we go. Let's try to make some common sense of this. Sorry, guys. What just happened here? I'm trying to get where I need to be. There we go. Better. Okay, so typical feed into a home is a 3/4 to 1 inch piping. Generally, it's 1 inch. Now, where is it coming from? We got a house with a basement. Again, we're talking about our middle of the row, 2-story, 3-bedroom, 1-bath row home in South Philly. Under the foundation, you'll see this piping is coming in on the bottom left of illustration 83. Now, this is coming from the middle of the street, right? Because that's where our big water pipes are. Now it's coming into the parcel. It's going to come up the foundation. There is a shut off before the meter, and then there's a shut off after the meter. This is your main water line. Now that main water line goes up to the ceiling in between the joist of the ceiling of the basement. Goes across the basement, and then you'll see there's a vertical piping going right into the water meter. Oh, okay, now I get it. So the water comes in the house and then has an option, a big T connection is here. So the water can drop down if needed to go into the tank. Or you'll see there's a shut off there if I need to shut that off. But where else is the water going in the house? Oh, so if we go across the ceiling, past the T, we see a inverted T going the opposite direction. And that T is going through the flooring up to the bathroom above it. And that's where the cold water line is going for the toilet. So that's how the water gets into the tank of the toilet. Okay, I get it. And if I continue further across the ceiling of the basement, I'll see an inverted T, which is allowing cold water, excuse me, to come up to the vanity for the sink. On that same note, you'll look at the water heater and you'll see that the water, excuse me, coming up the tank goes across the ceiling and is going up through the floor for the hot water. Everything is connected by piping throughout the home for cold water and hot water where it's needed. Again, this is a closed system. If the plumbing is not a closed system, then we're going to have leaks. We're going to have leaks in the piping where the joints meet or damage that has been done to a pipe to cause it to leak. In a crawl space situation, is just a shorter ceiling height to everything we just talked about with a standard 8-foot ceiling basement. The process of how the water comes in, how it filters through the water heater, how it's then on demand sent from the water heater up through the floor in the piping to either the sink for the vanity for hot water, or how the cold water works its way across the ceiling and shoots up through the flooring at different locations where needed for distribution. On a slab construction, you'll see that the piping runs through the slabs. See all those pipes going everywhere it has to go, but it's done through the slab construction. There's different types of piping, as you see on the right-hand side. This is the plastic version known as PVC. That's that white, hard plastic, often used for replace sewer lines. Sometimes it's done in black. And you'll see how the elbow joints work, how the pipe enters into an elbow joint, has a 90-degree turn, both in and out. And then there's the flexible plastic pipe known as PEX. You'll recognize that when you're in a basement and you'll see bolted to the wall near the water heater usually, and or to where the water line comes into the property, reminds me of a spinal cord. There's a center valve system in black usually, and to the right, all the flexible piping is blue, and to the left is red, hot, cold. And from here, is where you have options to shut off a particular flexed pipe or not, and where the hot water goes up one end and the cold water goes up another end. Hex piping. See the illustration further down? See, there's the black center, and then there are compression fittings as this goes out. Something to keep in mind is metal distribution piping. So, Philadelphia is a very old city. And those of you who sell in the suburbs, there are some very old farmhouses. In the 1900s, the water intake coming into the home was often lead. It is still possible that lead is entering an old home today from its source, a well, or from the street where the main water line is. In the 20s, they had upgraded to galvanized steel. And then in the 50s, we went into copper. Now, when in doubt, while you're at that home inspection with that home inspector, and this is an old property, and you're there with the inspector, and you know the house was built in the 20s or earlier, please ask the inspector to inspect the piping coming through the foundational wall for him to give his opinion on what type of metal that may be. If it happens to be a lead pipe, you now have a concern in your home inspection report of knowing is lead coming in through the water. Lead can be in our pipes, it can be in our old paint. So there's concerns both ways. Okay, as we scroll down, it talks about water softeners that are often used with well water, and they too would have to be inspected if that's the situation. Talks about different kinds of valves to shut off. There is a ball valve, a gate valve, a globe valve, a saddle valve. Just be familiar with the terms. You'll see here how it talks about water softeners with well water, how a water softener would be set up in a home that has such a thing. Not commonly seen, but just some basic idea how it works. All right, let's see. More filters, more filters. Garbage disposals. All right, let's talk about this. Okay, many homes have a garbage disposal. Often, obviously it's electric, and often by a switch on the wall. Things to know about it. Things to know is that garbage disposal doesn't take everything, or shouldn't take everything that you have in a sink. Hard substance like broccoli, the stems if you don't use them. Carrots, hard carrots if you've got it chunked up. Things that are hard, you just throw it in the trash. But if you're going to use the garbage disposal, it must have water running continuously to allow it to grind up the blades, or to grind up the product and push it through the piping to the sewer line. Always use cold water. And you're like, well, why do I have to use cold water? Because that's a motor that's working really hard under that sink. The cold water helps to keep the motor cool and preventing it from overheating. Reset. You'll note here on the illustration on the right, it shows the bottom of a garbage disposal. Sometimes things kind of get trapped in there. And there's a special key that comes with it that you would insert and manually outside of the garbage disposal. Your hand's not in there. This key is in there. You're going to manually try to release whatever is caught in the blades. And then you'll realize you have a free spinning blade. You've removed whatever was trapped in there. You will then turn on the water and hit the reset button to allow the motor to reset, and everything will run through it. Okay? On illustration PO14 on the next page on the left, it will show the wrench, how it's inserted into the center of the underneath portion of the garbage disposal, where you manually try to release whatever was jammed in there. Okay? On the right is hose bib. Remember, we talked about that very shortly, but this is really, really important. And you say, okay, what is this talking about? All right. On the inside of the house, where all these pipes are running, right? There is a pipe that runs from the inside of the house through the foundational wall to the outside of the house, where you hook up your hose to wash the car, water the plants, wash down the sidewalk, whatever it is you need to do. In October, you need to remove the water from this pipe that is penetrated through the foundation to the outside. And you're like, well, why do I need to do that? If water remains in that pipe and the outside temperature drops below 32 degrees, 32 degrees is where water starts freezing, it will cause the water to freeze within the pipe, causing the pipe to rupture. Now, you don't know it's ruptured until the spring gets here. And there's water dripping, and you can't figure out what the heck's happening. What's happening is you didn't drain the line, and now that pipe froze, and now we're in a hot mess. In October, you find the shutoff valve that goes to your hose bib, and you shut that valve off on the inside of the house. Now you're preventing any water to pass that valve. Can't go past it, right? Because you've shut it off. Meanwhile, though, there's still water from the other side of that valve through the foundation to the hose bib. Now you take yourself outside and you open the outside hose bib. Water will come out of there. And what water is coming out of there? The water that remains in the piping through the foundation. You have now released any water in that pipe. There will now be no freezing going on. You then shut your valve and you're good until April, when you got to open it up. All right. Let's talk about water hammers. Water hammers are found, not always, but are found in homes that have radiator heat. Radiator is a hot water heated system, not a hot air system. So we spoke about, when we were talking about HVAC, the difference between hot air and hot water. There is radiators that we know could be 4 or 5 feet across by 4 feet high in a room, in the dining room, living room, all throughout the house. And then there is radiator baseboard heat, which runs along the lower part of the walls in any given room, where hot water runs through the piping and lets off heat from that hot water. These hammer releases are set up to release air that sometimes accumulates in the pipe. causing a banging sound in the walls. You might remember this at grandmom's house when sometimes you would hear the walls bang and you're like, what is happening, grandma? And she's like, oh, honey, don't worry about that. That's just the radiators. No big deal. And it's not a big deal, but that's where they're at. Okay. Okay. Let's talk a little bit about drainage and airflow. All right. On the left-hand side here, you'll see on P016, it talks about drainage, waste, and vented systems. So I want you to get a visualization of any modern home in the suburbs. And if you're standing across the street, you're going to look and notice that there are all these pipes coming up through the roof. Well, the pipes are there for airflow and sewer gases to be released. Sewer gases accumulate and have to be released. Otherwise, they go in our houses and smell icky, right? So in this illustration, you'll see how all of the plumbing is somehow hooked up to this main vent that is going to allow the sewer gases to expel outside and above the roof line. Another thing that's really important, and you see it all the time, but you didn't know what it was about, is on the illustration to the right, where it shows a sink, and then there is the kind of crayoned in U under the sink. That is called a U-trap. Under every sink, you're going to see a U-trap. And your question is, why is there a U-trap? And what if you look under the sink and you don't see a U-trap? What is that telling you? Oh, that's telling you Uncle Joe's been here. And it's telling you that the importance of the U-trap was not appreciated by whoever installed this piping. Let's look how the U-trap works. The U-trap, or floor drain trap, noted on the next page on the left-hand side, gives a very good illustration. It shows how sewer gases going out. This water is leaving the house. Let's say the top of this drain is in the vanity sink, the bathroom sink. It goes straight down and then hits this U. But when it hits this U, the water expels out along with any gases. But as the used brown water and gases leave, there's still a valley noted that has water in it. So you're like, why is the water in it? Oh, the water is in it to prevent sewer gases from coming back up into the home. The water in that U-trap creates a boundary to prevent sewer gases from entering the home. See on the next illustration, P026? See, this home doesn't have the water in the U-trap. Why is there no water in the U-trap? Because this house has been vacant a long time and the water has evaporated. If you are in a home that is vacant and you walk in the home and you're in the kitchen or you may be in the bathroom and you smell icky, you smell caca, and you're like, what is happening here? The U-traps that are located under the sinks, under the utility sinks, in the toilets, inside the toilet has a U-tank in it to prevent sewer gases from coming up, have evaporated, causing the sewer gases to come up and give that nasty smell. All right, brief description on septic systems. Now, septic systems Whoa, sorry guys. Septic systems. Ah, there we go. Okay. Not many in the city, but the city still has some, believe it or not. So let's talk about sanitary sewer to the street. On the left, you'll see how a system works. There is storm sewer, which is that of the overflow from the roof, goes in the gutters, down the downspout, into a piping system that goes underground for storm water. Storm water is a different source of sewer than sanitary. Sanitary is brown water, dirty water. Okay, now, in this illustration, we have a couple variables. We have the second floor toilet is showing that when you flush that, the water comes straight down this big sewer line. When you're in the powder room on the first floor and you shut the water off from the sink, you'll see it comes across and hooks into that same sewer line. That same sewer line goes underground into the sanitary sewer system. In this illustration, it also shows a sump pump. A sump pump subterraneally is removing excess water. The water has to go somewhere. The pump pumps the water up and out of the house. And it shows here out onto the surface of the soil from the house. This happens in the suburbs. Sump pumps may not discharge in the storm sewage and or sanitary sewage system. But in the city of Philadelphia, it is allowed to discharge in a utility sink and go into the sanitary sewer system or storm system. When it's in the suburbs, the issue is it has to discharge at least 6 feet from the house, if not more. Okay. Now, on a septic system, when we flush the toilet and you have a septic system, you'll note on the illustration on the right here that you flush the toilet and the water goes down the pipe and leaves the house and it goes into a septic tank. The septic tank holds the water, as you see in the next illustration below, at which time the solids settle to the bottom and the scum and such comes to the top. At some point, when the solids have accumulated too much on the bottom and the brown water is in this tank too high, it has to have a runoff. And the runoff exits and goes into what is known as a leaching field. It goes further down the parcel and is discharged into the soil by massive PVC piping with these little holes that will discharge the brown water. Okay, here we go again. If you are selling a home, primarily this would happen in the suburbs, that does not have public sewer. It has private septic system. It must be inspected. You have to have your due diligence done by your buyer. An incompetent septic system can cost $30,000 to $50,000 to replace and correct. It is staggering. It is must be done. Okay. All right. Talks about a sewer pump. Whoops, a daisy. All right, here. we talk about sand mound or mound septic systems. This is something you might see in the Poconos. How does this work? Well, there is no public sewer in the street, so the dirty water goes into the septic tank. The sludge goes to the bottom. But as the sludge and the solids fill up, it has to overflow. The tank has to go somewhere. It will overflow into a pump system. The pump system will then pump the dirty water up to a mound of gravel or sand, at which time the dirty water is released into this gravel or sand, and then it is absorbed and makes its way through there and purifies it back into the soil. So many times on the homes down the shore, up the mountains, you will see these humps of ground in the back. The hump of ground is where the sand mound is for the septic. They often have well water too, not public. And that obviously is nowhere near the sand mound. So if the sand mound is in the back of the house, the well would be in the front of the house, or vice versa. The two may never be near each other, because you don't want the water going into the well that is contaminated soiled water, right? Has to go through the whole system of gravel and sand to help purify it. Okay. And how does stormwater and sanitary sewer go to the street? Just as we showed earlier, it always has to go underground to the main distribution piping in the street. No. Okay, gas valve. Next page. On the bottom right, exterior gas meter and lockable valve. It says exterior, but often, again, let's talk about our 2-story, 3-bedroom, 1-bath center of the row home in South Philly. This gray meter is often found on the front wall of the basement. Why? Because the gas line is coming from the street as a public utility, and it's going to enter through the foundation. Need to understand that this gas meter has a valve. If in case of emergency, has to be shut off. And there is also a vented regulator to help remove any air that might be coming in through the gas. Okay. When you do your final walkthrough on a property, you are to take a photo with your telephone of the gas meter and see all those numbers in the front. Click, click. You take a picture of that, along with the water meter, which we will see how to open that and take a photo. Why do we do that? In Philadelphia, water and gas are lienable. So we need to make sure that the seller is paying their portion of what has been used. At the table, at the altar, at the HUD, we are even Steven, who owes what is needed for these lienable municipal services. Okay, you take a picture of the gas meter, you take a picture of the water meter, and you show it to the title clerk. It shows an illustration here for propane. Now, propane is used in the city. Propane is used in the suburbs. For instance, my son lives in Pine Valley. His home is oil heated. He has propane for his gas range and his gas dryer. He has electric through the rest of the house for every other thing needed. Central air, for his electric for everyday uses. Propane is used in the burbs also. For gas cooking, some people don't care for electric, and so they will set up a propane tanks that are refillable. The newer homes built in the last 20 years, often the propane tanks are below ground, so nobody can see the tanks. Talks about oil heat. Okay, oil heat. How does this system work? Well, note on P003, the piping outside of the home indicated as vent and fill pipe. Just as a high efficiency gas heater, which we talked about last time, you will have venting outside of the home and PVC gases coming out of a home. Well, the venting works here similar. In this illustration, we have to get the oil into the tank, which is in the house. So outside of the tank, there are intake valves that the oil company comes, hooks up, and pumps in hundreds of gallons of oil into a tank. Now, this is where you have to pay attention. In older homes, there's not a lot of newer homes built with oil. But if a home is 40 or greater years in the suburbs, make sure you read the MLS sheet to note the type of fuel unit used to heat the home. If it's oil heat, the tank is either going to be in the house or buried in the ground, such as Levittown. The tanks are buried in the ground. If the property, and you read it in bright, says that the HVA system is gas, yet you show up to the property, two-story, middle of the row home, and you notice the hookup for oil on the outside wall of the property, on the foundation. There's a hookup, like 3 inches in diameter, a piping with threading. That needs to set off alarms. That's telling you that once upon a time, this house had oil tank. You go in the basement and you say, nope, it's truly a gas-fired system. And you do not see the oil tank. So the oil tank was removed when the gas system was installed. Here is a fear factor. If the fill pipe on the outside of the property was never sealed off properly, a mistaken oil delivery man could hook up to that home and dump 500 gallons into somebody's basement because there is no tank to catch it. This happens on a regular on a regular issue. So concerning. If a home had previously been an oil-fired system, you have to make sure that the fill piping on the outside has been abandoned properly, so that accident could never, ever happen again. Okay. Crawl spaces and foundations. Okay, we're looking at, on the left-hand side of the illustration here, foundational walls. This is a concrete block foundation noted on the left-hand side. Blocks are added vertically with mortar to create a foundation. The one to the right of that is known as a poured concrete foundation. Notice there are no horizontal lines, because in building this home, a form was created, liquid concrete was poured in the form to create a solid wall of concrete, and then the forms are removed. In a crawl space, there could be a much smaller, which we know it's going to be in height, right? It's not going to be 8 feet high. It's going to be maybe 4 feet high of concrete, but it's done similarly with the blocks added on top of each other with masonry to create a wall. Or you have a slab foundation, which it's only concrete poured in a short form, and this is used in warmer climate for the foundation. Pilings. Where would you find pilings? Excuse me. Pilings are used for used for poor soil conditions. Pilings are supported by friction to soil or rock. It's by a functionality. This is something you would note often down the shore where it's sandy soil, lots of water. Large pilings, large circular columns, often, sometimes wood, will be hammered deep, 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 deep until they hit rock to support the weight of a home above it. That's where and how that's used because of the soft soil all around it. They have to pound it down to stiff soil. Okay. Basements. Excuse me. Let's look at basement concrete block, newer construction on the bottom of page, on the right side of page 62. This is a slice to give you some illustrations here. Note that this construction is of block, and we know that because we see the block illustrated here. We also see that this particular property has a sump pump, and the sump pump has to discharge somewhere. So this sump pump has PVC piping that comes out through the foundational wall and will discharge away from the house. There's also floor drains that you may find in this concrete floored newer construction, so that if water does infiltrate the house from the walls, it can go into a floor drain that would discharge away from the house. Termite sheathing that is used to prevent termites from entering a home. Notice though one thing here on page 63 where it talks about termite sheathing. Notice where it says 6 inches above grade. Grading means the way the soil is placed next to a property. Every inch high is 1 foot away from the house. So for instance, this is showing a 6-inch above grade. If rain was to run down the side of the house because they didn't have gutters, it would stop right there where the concrete block is. If the grade is not steep enough, which is 1 inch of a grade per foot away from the house. So for every inch away from the house is decreased by every foot away from the house. So every 12 inches away from the house, the grading has decreased by 1 inch. So 6 feet away from the house should be a 6-inch differential than the dirt up against the house. To allow the water to run off away from the house as gravity pulls it away, rather than tipping towards the house to enter through the concrete or cement block. Construction. Different forms of construction. Now, what is a load-bearing wall? You're in a house with buyers, and they say, God, I like this house, but if I could only remove this wall, that would open up this kitchen and living area. Can I take this wall out? They ask you. What is your response? Your response is, I am not an engineer, architect, or home inspector. I don't know that answer, but we can find out if it can be removed. A load-bearing wall is just that. It's a wall that is designed where it is to support the weight above it. So all exterior walls are going to be load-bearing walls because they need to support the entire perimeter of the property. Some interior walls are there just to divide the room, not to give additional support to the weight above it. And that's where those walls can be removed and or other carpentry work can be done to re-support a load-bearing wall if it needs to be removed. But this is over our pay grade, therefore we're not getting involved. It talks about floor trussing. It talks about balloon framing. It talks about floor joists. Floor joists will be mentioned in a home inspection. A floor joist is what you see when you're in an unfinished basement and you look up. They are the joists that go from left to right on the property and bury into the foundation. 2x8s, 2x10s, 2x12s, 2x14. 2x meaning 2 inches thick, which is really a term. It's often 1.5 inches. By the span, is it 8 feet long, 10 feet long, 12 feet long? So it's important that this is very much physics, that the right size of joist is there to support the home. Subflooring goes and talks about different types of subflooring. 1/2-inch subflooring, plywood, 3/4 inch engineered, 3/4 inch hardwood flooring, 3/4 inch lumber. Different types of beams. There's laminated veneered lumber, laminated lumber that is done in sheets and factory glued. There's solid wood lumber. There's what is known as an I-beam of steel. There are various types of supports. In this illustration here is a open concept of a new construction, and words that you will hear, especially the word header. Note, the word header is above the rough cutout where a window is going to be. That is a support system to hold the weight above it. You'll also note that there are always headers above the door. Wherever there is going to be an opening, a header is needed to hold the weight above it. These, excuse me, verticals on these walls are called studs. And studs should be within 16 inches on center. 16 inches apart is the proper way to do this. Bricks. Let's talk about bricks. We're running through this. Page 66. Note I have the word pointing. Pointing is important for you to understand. As you go down further, I want you to see where it says brick home elevation. It talks about the lintel that is above this window. That lintel would be of steel, usually, that extends further than the opening of the window in the mortar between the bricks to help hold the weight and support above the lintel, because there's a void here. That's where the window is. Pointing, though, is in between each bricks. When you read a description and it says, home was recently pointed, that means that the masonry between all of the bricks has been replaced or added to, because over time the mortar has deteriorated, fell out, and has left gaps in the mortar. So the mason comes and replaces the mortar between each one of these bricks. That is what is known as pointing. On the right-hand side, we talk about stucco. Stucco is our enemy. Stucco is not our friend. Stucco causes many, many transactions to fall apart due to the fact it wasn't installed properly. Laziness is a big problem. The older the stucco, 40, 50, 60-year-old stucco, the better chance you have in the home inspection that it was installed properly. Newer in stucco is a big problem, and stucco inspections need to be done. If a stuccoed home has not been done properly and the absorption of moisture has gotten in there behind the stucco, mold and mildew will grow. And that is where Pandora's box happens. So again, a stucco home, you have to have the conversation of having a stucco specialist, not a home inspector, but a stucco specialist come out and do the necessary inspection for that. We talk about different types of windows, which vary, such as the double hung, which you see here on the left. Double hung window is when the window at the top can pull down and the window on the bottom can go up, right? We can go up with the window or down with the window. That is very common type of window. We have garage doors and garage door openers. Garage door openers need to be inspected by a home inspector to make sure that the I-beam at the lower part of the garage door opener is working properly. So if the garage door is coming down and something breaks that I-beam, an animal, a ball, an individual walking, that garage door stops immediately and does not continue down to crush whatever is under it. Garage door openers, excuse me, can be electric and they're automated through a button, or there is a hand release system that can be used either A, when electricity is not available, there's an outage, or in case of an emergency. You need to know as a homeowner how to manually release the door. We're going to talk about ventilation of a home. A home actually breathes. It's a living creature, a home. And how does the airflow work? Excuse me. Airflow exchanges out through the roof, and there are various types of roofing ventilation that will allow the house to breathe. Also talks about typical wall sections for insulation of fiberglass and styrofoam. Attic ventilation here on page 73 talks about how the air comes up through the attic and is expelled on the ridge. That is called a ridge vent ventilation that removes heat and moisture from the attic space. It is important that moisture leave the attic. Excuse me. If a home is on a high water table and moisture in the home is at a higher normal level, that moisture will raise above the roof, up to the roof, excuse me. And you will see the damage of moisture up on a roof, not from the roof obtaining moisture, but from moisture finding its way up from the basement area. So removing of heat and moisture is very important. All ventilation, often found in a home inspection, the powder room that has been added that was never planned upon on our 2-story, 3, and now a half bath middle of the row home in South Philly is vented to the crawl space. That is incorrect. It is to be vented to the outside, to the roof. Excuse me. Different types of roofs. I'm going as quick as I can. Different valleys and dormers. These are verbiages you should become familiar with. Pitches of roofs, shingle insulation, tile insulation, and our flat roofs that are customarily seen in roofing in Philadelphia. Chimneys. Let me just say one thing really important about chimneys. Very, 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 very important. Old chimneys were lined with terracotta, a clay-like substance. If the home inspector looks down the chimney, or if they put a mirror inside the cleanout and cannot see up the chimney due to something blocking, that is also blocking carbon monoxide, very, very scary. A chimney has to be opened and in good condition. So it's very important that that is inspected to as thoroughly as possible. Okay, guys, I'm going to let this go. I certainly hope this has been helpful for you. Please take the opportunity to read it further in depth. More importantly, you must go to your home inspections. Okay, guys, hope this helped.